Hello, guys. Okay, so we have the audience with us. We will be waiting for a minute and we'll be seeing that if everybody else is also joining, and then I'll be starting. Okay. Till then, the existing audience can just confirm that if I'm properly audible and visible. People, you can write yes in the chats. Just confirm in the chats, please. Okay, I've gotten confirmation from Abhishek. Thank you, Abhishek. Okay, all right. Okay, thank you, Priyank. So I think we should begin now. So, people, welcome to this session. And as you already know, we are running this series for Solving for India Hackathon. And this is just the next lecture for that series. That hackathon is right now in its first phase, and that is at institute level. And with all these videos that we are coming, you guys are getting the help for developing even better apps. And today, for the same, we have Arvind Kalra and Pranav with us. And these guys will be helping us knowing that how we can build a blockchain product. And for that, Arvind and Pranav will be continuing. So I would like to invite them both here. And you guys, please may continue. Thank you. Arvind and Pranav, just give me a second. Yes, Arvind is here and Pranav is here too.
Um,
So
hey
people,
guys.
Hey folks, hey everybody. Uh, okay, looks like people are on the live. I'll start with a quick introduction for myself and then pass on to Arvind. So, my name is Pranav. Huge thanks to the team at GFG for inviting us to their hackathon series as blockchain mentors. We're going to be talking about how at the hackathon you guys can use GCP or Google Cloud Platform to deploy your own Geth node. Then we'll talk about what a Geth node is, what are the benefits of using GCP, how you can save a lot of money, and then finally we'll deploy our own cryptocurrency using that Geth node connected to a crypto wallet, and then do some transactions on this node. So, let's get started. Arvind, over to you.
Hey guys, I'm Arvind Kalra. So thank you to the GFV team for inviting us to this. So let's get started. So as part of this session, it would be divided majorly in two parts. One would be I'll introduce you to Google Cloud platform, how we can create an instance, how we can deploy a Geth node, and then once everything is done, I'll take it over pass it over to Pranav, and then he can take it, and then he'll be deploying a contract over the development Ethereum blockchain that we have deployed on the VM instance. So yeah, let's get started. Devashish, can you share my screen?
sure, Pranav. Sure, Arvind. Okay. I
Yeah.
hope it is visible to the audience. Please just confirm in the chats if it is visible to all.
Okay.
Chats. Okay. I think it's visible. You can continue, Arvind.
Okay. So I hope everybody can see my screen. Right now, I'm the Google Cloud Platform homepage. So when you land on this platform, the first step is to start using the platform, sign up on it, and everybody, most of us will have a Google account. So you would just see this button called Start Free Trial. We can go ahead, click on it. So Google Cloud Platform provides a free trial for all the users. Most of the services are paid, but as it is mentioned over here, we get $300 of free credits. So during our initial months, we don't have to pay anything to Google Cloud Platform while we are developing. So they support the developer community. So they just start from big companies. So yeah, over here we need to provide the size of application, and there is a big form because eventually we'll have to pay for the product. So in the next screen, they will ask us for our credit card details. I'm not going to add those details over here during the call. So I'll take it to a different account, which is already set up. I'll take you there. So it is console.cloud.google.com. I'll go to that page. I'll move to a different account. Yep, so here I am. So as soon as you complete the entire registration process, you will land on this page. You will already have a My First Project. So everything that you do on Google Cloud Platform should be inside a project. So I already have a My First Project, but for this session, let's create a new project and do everything in it. So I'll go ahead and create a new project. I can name it anything. For now, I'm naming it GFG Blockchain Session. I'll leave it like the location as it is. So yeah, I have the new session. It is right now in creation in progress. I guess it might take a couple of seconds. Yeah, so the session, the project is created. Now on Google Cloud Platform, we have multiple services. For for deploying our Get node, we will be using a virtual machine, the VM. So over here, I'll click on create a VM. But while the VM is created, I'll give a brief about what a VM is. So consider your machine. Right now, when you are developing on your own machine. But let's say you want to go ahead and develop on a remote machine. You want the code or the product that is deployed on the machine to be available over the globe to anybody. So for that, you will need a remote machine. So VM is a virtual machine that can be set up on Google's, what do you call it, Google's setup, and then we can remotely connect to it. So first of all, to start use any new feature, we need to enable it for our account. So I need to click enable. It will again take some time. It'll again enable the compute engine API for me. So why it is called compute engine? Because it is actually giving us some computation power which we don't own. It is present in Google's system and Google's server houses, and we are just remotely accessing it and using it. So let me just wait for it and see if this gets set up, enabled for me. It's taking longer than expected. Let's wait for a minute more. If it takes more than that, we'll move to the other project that I already have. Just open the other project itself. I guess it's taking more than expected.
You might want to refresh your screen.
Yeah. Okay, now the API got enabled for my GFG blockchain session itself, so we can use it. So now I can click manage, and I can go inside the compute engine API that Google Cloud Platform provides. So over here, I'll go into the compute engine, and inside compute engine, I'll go to VM instances. Okay, I'm already on VM instances. So right now you can see I don't have any instance. So I don't have any virtual machine that I can connect to. So to deploy our development chain, I'll have to create a new instance. So hence I'll click on create instance. I'll provide a name to it. I'll call it Ethereum get node. we can select any region. So these regions are actually the different server houses that Google Cloud Platform has. So since I am in India, I'll select the Asia South to Delhi region. Next, I'll select the machine that I want to use. So there are multiple options. We can select the machine based on requirement. But right now for this session, we are going to use AMD powered machine. So I'll select T2D. So let it just, right now it's calculating the approx monthly cost that I'll have to incur if I use this machine. But because I have free credits, I don't need to worry about the cost right now. In the next step, I'll select a boot disk. Right now, if I click on change, right now the image that is selected is Debian, but for my development and my deployment, I'll need Ubuntu. So I'll search for Ubuntu. I'll select that. I'll go with the 18.04 version of Ubuntu. Yep, that is selected. I select the boot disk. I'll go ahead. Now, our traffic that comes into the instance can be of two types, HTTP and HTTPS. For now, I'm going to select allowing both of them. So I'm allowing both HTTP and HTTPS traffic. And then I'll click on create. So yeah, as you can see, the instance is right now being created. It is basically spawning the instance for me so that I can connect to it and do my work. And it will provide a external IP, an IP address, public IP address that I can access from anywhere and then get information that is present in the instance. But yeah, there are some permissions, etc., that we can set up inside the instance so that I can access only certain information from the instance. So let's wait for the instance to be spawned up. Yep, so the instance is spawned up. So right now, this is our Elastic IP. If I click on the Elastic IP, it is being connecting on HTTPS. And as we know, HTTPS runs on 443. So when I just hit this IP, it is checking for port for whatever is running on port 443, and whatever is returned from that port will show up here. But right now, since our instance is just created, there is nothing that is running on neither port 443 nor on port 80. So if I search for this IP, I'll see that I cannot reach the site. So now we need to go ahead and basically deploy something on this instance. So to connect the instance, we can use a protocol called SSH. SSH protocol runs on port 22, and I'm going to remotely access the instance. And using that, I can run commands on the machine. It's a normal Ubuntu machine, so I can run all the commands that I can run on my personal Ubuntu machine as well. It's establishing the connection. Let's wait. Yep. So as you can see, the terminal is here. I am connected to it, and now I can run my commands. If I try to do ls on it, nothing is present right now. So as I mentioned that nothing is being returned from this IP address. To return something from here, I need to run something on on the instance which returns a response on port 80. So for that, there is a service called Nginx. I'll install that, run that, and Nginx runs on port 80. So as soon as I do that, I'll see some dummy setup of Nginx on the screen. So I have this doc open for me. I'm going to use the commands to install the Nginx. We'll share the link to this doc on the chat after during the end of this session. But for now, I'm going to just sudo apt update because it's updating the app repository. Then I'm going to install Nginx. Yes. So as we can see, Nginx is installed and it is running right now. To check whether Nginx is running or not, we can use this command called systemctl status Nginx. So it will tell the status of Nginx. And as we can see, the Nginx is running and it is active. So now if I go to the IP address, I refresh it, and we can see that it returned welcome to Nginx. So something is running on port 80 and it is being returned over here. Now the next step is to install the get node because that is actually something that we will be using right now. So for that, I'm going to use another set of commands. So get can be also be installed using the apt repository, but we need to add a new apt repository for that. Just doing it right now.
Hey, Arvind, you want to talk about what get node is while you set it up?
Okay, yep. So while I'm setting up the get node, I'll give you a brief about it. So if we understand blockchain, there are multiple nodes that are run on blockchain which actually store all the information, that all the transactions that happen on the blockchain. So get node is one of that node. So why it is called get? Because it's a short form for Go Ethereum. It is an implementation of an Ethereum node written in the Go language. So when I run get node, it's actually a new node that is being spawned up, and it will connect to the actual Ethereum blockchain, and then it will start storing all the transaction. It will first pull in all the history of all the transactions that have already happened on the chain. Then it will start syncing the chain, and now we can use this node to actually mine new transactions, mine new blocks. So that is what a get node is. But as we talk about it, Ethereum is a huge blockchain. There are a lot of transactions that have already happened. So I'm not going to sync it with the mainnet, else we will be just waiting for it to sync. It will pull the entire data of the Ethereum blockchain to the Genesis node, which will take a lot of time. So for now, for the sake of this session, we'll be spawning up a dummy development chain on our network using the Get implementation, which is the actual Ethereum implementation. So it will be a blockchain that will be running on this system, and we will be remotely accessing it via MetaMask, just like we connect to our mainnet. So I'm running all the commands.
So
Quickly, okay,
basically,
install.
this node that you are going to run is going to behave exactly like the Ethereum blockchain, but it won't have any latency that the actual blockchain does. So it's going to significantly reduce development time when we are actually writing code on Ethereum.
Exactly.
Correct.
So now after running all these commands, we can see the get node is installed. To check that, we can write get --minus help. And when I do that, it returns all the keys that I can have to actually spawn up the get node. So when I start the get node, it will run the blockchain, and then there will be a port 8485 through which I can connect to this blockchain to actually send the transaction. It would be the JSON RPC API endpoint that I'll be using. But as we know, our instance can be accessed through this IP, which returns whatever is running on port 80. Now, after I spawn up the get node, it will be returning on 8545. So to make sure that the IP directly returns the basically through the IP, I am able to access the JSON RPC endpoint of get node. I need to create a reverse proxy. So to do that, Nginx provides us. So right now, Nginx is just returning this dummy page. I can update it so that when I hit this IP address, it proxies me to the 8545 port. So to do that, we need to run a couple of commands, and I'll just show you. So basically, Nginx has a configuration. I need to open that configuration and update it. So I'm going to open that configuration, and when I'll go to the folder where the configuration exists. So I'll go to etc nginx sites available and default, because right now we have not done anything, so it is a default configuration. We can see the entire configuration exists. So right now nginx is listening to port 80, and on port 80 it is just returning this files index.html. So right now I'm going to do I'm going to update this block so that it starts proxying to the 8545 port that will run using the get node. So let me just copy whatever needs to be pasted over here. Yeah, I'll share this doc as well that I'm referring right now. So I have updated it. Now I need to just save this file. And once this is saved, I need to test whether Nginx accepts this configuration or not. So for that, we need to write sudo nginx -t, which says the configuration file is okay, the syntax is okay. Now I need to restart Nginx. So once I restart Nginx, if I go back to the IP address, right now it is returning welcome to Nginx. But now, since we have an updated configuration, it should return whatever is present on 8545. And right now, if I can see, I have not run anything on port 8545. So when I do this, it will just say 502 bad gateway, which is expected right now. Now I'm going to go ahead and run the get node. For that, we can use the get command. I'll explain what exactly this command is. So you can see we have done get, plus we need to expose an HTTP endpoint, which will be used by MetaMask to actually send transactions. So that's why we gave the HTTP flag. Then we have HTTP coarse domain because we don't want to have any coarse limitations. Anybody should be able to connect to it. And then we are providing the different APIs that we want to use, Web3, ETH. These are the different things. So using ETH, we can fetch the balance of anything, send transaction, etc. And we are also opening a port for WebSocket. We might not need it, but it's good to open it. Plus, I have given the dev flag. So with the dev flag, it will just create a dev blockchain. But if I have not given this dev flag, it would actually start a node for the mainnet and start syncing whatever is present on the mainnet Ethereum blockchain. So yeah, so I'll just enter.
So just before you run, I sorry to interrupt, but I saw that the coarse domain flag only had an empty double quote. We
Okay, yeah, we
probably
need
want to add a star to it.
Yeah, makes sense. I think I missed that. Yeah, you are correct on that. Thanks for keeping me out over there.
No
I'll add
worries, man. That's why I'm here. Cool.
Yep. So the node is started. I can see that there is this blockchain that has already been started. Every blockchain has a chain ID. I can see the chain ID for this development blockchain is 1337. Then there is this Coinbase address. So I'll explain what this Coinbase address is as well. So when you run a node, you start actually start helping the blockchain in mining new blocks. But now since we are, you start helping in mining new blocks or producing new blocks. So whatever reward that is received after mining the new blocks or whatever gas that needs to go to the node comes to this address. So this Coinbase address is used by the miner to collect the gas fees, etc. So right now we just have this Coinbase address and I can use it to transfer some tokens to another account that will later be used to deploy a new contract. So since I mentioned in the beginning that Pranav will be helping us out in deploying new contracts, I'll request Pranav to send me a Ethereum address over which I can send some ETH so that eventually you can start deploying the contract.
Yeah, let me send it on the private chat that I see here. Can you see that?
Yep, I just received it. Okay. I'll run the send transaction function. Yep, over here. Yep. So over here I'm sending the ETH from the ETH.Coinbase address. And in the two, I'll paste the Ethereum address that Pranav just shared with me. Okay, I think I copied something incorrect. Just give me a second. Copy the address that Pranav shared. Excuse me. And over here, I'm saying that we need to, so whenever we send transaction, actually transfer functions, we see in MetaMask that we are actually transferring 1 ETH or 2 ETH, but that is not the actual unit that is being sent. We send in Y units. So over here, I'm converting 50 ETH into Y. So when I click on it, it will actually send 50 ETH to Pranav. Excuse me. So as we can see, the block is mined and we have commit the sealing work and everything. So now when Pranav connects his MetaMask to this blockchain, which is the RPC URL for which is this. Okay, did I do something incorrect? Pranav, what was the port that I think I added the wrong port? Okay, I think I know the issue. While I set up the Nginx, I think I added the wrong port.
Let's go check
proxying
it out. Yep.
I'm proxying it to 3000, so we need to update it to 8545 because that is the port which is being used for RPC connections. I'll save it. I'll test on Nginx that if it is okay or the syntax is okay. I'll restart Nginx and then again start the get node in dev environment. Yep. Now if I refresh the page, it does not return anything. So that means the 85455 port is running, but right now it is not returning anything. So that's why I got that empty page. Now I'll again have to send some ETH to Pranav. I'll just do that. Yeah, the ETH is transferred to Pranav, and now over to Pranav. Pranav, can you share your screen?
Absolutely, man. Folks, if you can, present my screen, I'll get started. My screen is shared, but I'm not seeing it on the stage. So anybody in the backstage, if they can help me out with it. Jay, can you, help us out here? I'm not seeing my screen shared on the stage right now. Okay, looks like we have some sort of a delay. I'll quickly wrap up, what Arvind has done so far. So, the intent of the tutorial is to get, the folks watching and the folks attending the hackathon be able to deploy and develop on Ethereum. Now, that can be a tricky and challenging process for somebody who's just starting out. So, what Arvind basically did was he used GCP's AMD VM instances running on the GCP cloud to set up a pseudo blockchain for us. It's going to behave exactly like the Ethereum blockchain, the most popular, the most diverse, the most popular blockchain with the highest count of developer activity out there. It's going to create a clone, and we are now going to do all the development on that clone now. Looks like Devashish is back, and I'm gonna get started on the development part. So Devashish, basically, if you can, put my shared screen on the stage,
Yes,
we
sure.
can get started.
Yeah.
Thank you.
I think there is your screen and it is visible to everyone.
Looks like it is. I can confirm that on the live. Awesome.
Yeah.
So
All
what
right.
I'm gonna do first is basically spawn a new wallet. For those of you new to Ethereum, basically the most common wallet that we use is MetaMask, and a wallet is how we connect to the Ethereum network. So right now, as you can see, if I zoom in a little bit, okay, looks like I can't zoom in, but I'm connected to a network called Sepolia. It's very similar to the network that Arvind just ran. So we're gonna switch to our network, and that is very straightforward. You open MetaMask, click on Add Network, and you'll see a bunch of networks listed here. Now, these are all pre-set up networks. So I'm going to click on this Add a Network manually here, and I'm going to call it GFG Blockchain Demo. If Arvind will be kind enough to share the RPC URL with us, I'll add that. So the RPC URL is going to be the URL that our Ethereum node is running on. So the VM instance that Arvind just created for us, and the chain ID is going to be 1337. So this is the generic chain ID that Geth nodes start on by default, and we are just going to use that. The currency symbol is going to be ETH for us because that is the currency we are working with. And I'll just
Pranav,
click on save.
okay.
Go ahead. Yeah.
I was just going to ask you to remove the extra slash towards the end of the URL, but I guess that worked. So
Oh, that
can go
works.
ahead.
Yeah. MetaMask could have stopped me otherwise. So where was I? Yeah. So in MetaMask, if you'll see, now you should see the 50th balance. And in the real world, that is a lot of money. I'm sure everybody here knows the price of Ethereum right now. So this is going to safely carry us through the demo and through our development process, which is another, advantage of running a Geth node and using that for development. There are a bunch of test networks out there, but the biggest problem you will run into with them is that even there you have to do some mining. You don't have access to unlimited funds like we have right now, and that can become a major blocker when you're doing rapid development. That being said, we are going to start deploying our cryptocurrency, and the best way to start that I find is using the Open Zeppelin wizard. It is a really straightforward, simple to use code generator, and we are going to launch a token called the GFG coin. with a symbol called GFG, and we are not going to make it mintable. And as you open the Zeppelin wizard, you'll see that as you take multiple things, it's gonna make your contract or the code more and more complicated. We're going to keep it simple for now. We'll just make it mintable and ownable, which means that only I, the owner of the contract, can mint new tokens. And then I'm just gonna click on this button called Open in Remix. Now, what this is going to do is it is going to spawn up an online IDE called Remix, which is the most common platform for developing Solidity contracts. Once that contract is loaded in the IDE, you should see the code that you wrote in the wizard inside the IDE. Once that is done, all we have to do is click on this compile contract button. And there is a chance that you might not land on this page by default, in which case all you have to do is go to the first option in this sidebar, click on create new file, create a new file called gfg.sol. Sol here stands for Solidity because that is the language that we're using, and paste the code from the wizard along with the license into the contract that you just created. It's going to give you a warning that you have just pasted the code from an editor, and that is just to make sure that you know what you're doing. Since we are in the development mode, that is not much of an issue for us. Once we have the code, we are just going to save it, and the compiler here should show a green tick if it compiled with no errors. We'll go make sure there are no errors inside the compiler, and then click on the second option from the bottom, which says deploy and run transactions. Now it's gonna give you a bunch of options, remix, VM merge, blah, blah, blah. We are looking for the injected provider. The injected provider is basically how you are going to connect to the wallet. So our wallet is going to be the MetaMask wallet. And when you open that, it's gonna say your current account is not connected. All you have to do is click on the first account, which is the account, that we got the 50 ETH in, and click on connect. You should see the address that at the top here present in this account tab here. And this is how you know that your wallet is successfully connected to the IDE. So once that is done, all you have to do is click on deploy, and that should automatically open the MetaMask wallet for you. I'll quickly go over a few things that you can see here. So what it's telling you is that it's going to cost you this much ETH, and part of that is going to be the gas, and part of that is going to be the amount that you're sending. To deploy a contract or to do anything on blockchain, you basically have to pay some fee. It's kind of like AWS credits or GCP credits. GCP is kind enough to provide us 300 credits to do development. Ethereum doesn't do that, which is another reason why you don't want to rely on the mainnet for testing every time. You do testing development on a GCP instance using a get node. Once you're confident it is working, that is when you move to the mainnet. So coming back to the tutorial, once you have validated that the contract data is good, we are not going to go into the details of that. You click on the confirm button, and it's going to bring you back to the IDE. The green tick below and the deployed contracts list is going to confirm that your token contract is minted. And that's it. We have basically deployed our GFG coin onto the Geth blockchain running on our GCP instance. And let's try to interact with it now. All you have to do is click on this contract here, and it's going to show you all the functions present inside this contract. Now, some of the functions here are going to be mint, transfer, allowance, and balance off. Now, let's quickly check what the balance of our account is right now. I'll go and paste my address from the wallet here and click on call. As soon as I do that, my IDE is going to call it and return this value 0. The 0 simply indicates that I don't have any GFG coin right now. Let's add some coin to our token contract. Let's add some coin to our own wallet address. So what I'll do is I'll copy this value from my console and open the mint function and paste the amount in and copy paste the address. So what mint is going to do is it's going to send this much amount of GFG coin to this address. Now, I'll take a moment to explain why I added such a large amount. Basically, Ethereum doesn't understand decimals, which is why we have to, give it a very large value and tell it that it's, supposed to have as many decimals. The contract that we are using, so it's actually, hang on, let me see if I can zoom out. Yeah. So the contract has, this library called ERC20 imported, which takes all of that abstraction away. So if I just copy, 1 followed by 18 zeros and click on transact, it's going to show me what's going to happen. Now, again, it's going to cost me some gas fees to transfer this token. And when I click on that, I'll see that the block is mined. Next, when I go and click on my balance, I should see all of this token present in my wallet. Now, my address. What you can also do now is that right now, if you open MetaMask, you'll see that some of the Ethereum has been spent. And since we know that we minted some token with it, we would like to see our assets present in the wallet as well. What you can do for that is click on this import tokens button at the bottom, and that should open this import tokens modal. So it will tell you that token detection is not available on this network. So we are going to have to do that manually. It's going to ask you for the token address, the token symbol, and the token decimal. So let's see what happens when you populate these values. To get the token contract address, all you have to do is go back to your deployed contracts list here and click on this copy button next to the GFG coin. When you copy that, looks like it closed the wallet. Let's open the wallet, click on import again, and paste that address. Okay, looks like it says personal address detected. Let's try that again. We probably did not copy it properly. Open the wallet, click on import tokens, paste it. There we go. So you'll see that it auto-populates the GFG symbol and the token decimal. And when I add the custom token, you're going to see that I have 0.1 GFG. So to reiterate, we actually sent 1 followed by 17 zeros, but all we are seeing is 0.1. The reason for that is that Ethereum only understands whole numbers, which is why we have to tell it that every value that we sent is actually divided by 10 to the power 18 decimals. So when you send 10 to the power 17 as amount while minting, you actually get that divided by 10 to the power 18, which results in 0.1. And yeah, so in summary, what we have done is essentially deployed our own cryptocurrency on a Geth network and under 40 minutes. And that's really about it. Please, if I think now is a good time to take questions if we have the time for that. Yeah.
So, hello, audience. I hope this session was very informative to all of you because I believe they have told end to end how things are working. And I really hope that this is going to help you improve your applications that you are making. And if you have any questions, you can give that in the chats. Till then, I think Arvind or Pranav, you can take Dave's question. It is there in the chat.
All right, let's see. So Dave says, I'm developing a project on blockchain and there are going to be two interfaces. One is student and the other is organization. So how can I show these two interfaces on different computers without using a domain that is for free or in a cheap price without the local host? So, I don't think this is directly related to what we talked about. But the GPC node that we are running, that should be accessible anywhere. You can, in fact, deploy your code to a GCP console, very similar to how we deployed the Geth node, and just use the IP like we were using for our RPC URL to access the HTML or whatever format of the interface that you're using. Like Arvind mentioned in the beginning, they provide you with 300 credits, which should be more than enough to carry you through the blockchain project.
Yeah, I hope, Dave, that answers your question. And for everyone else, I really hope you are getting something that you have not yet learned. It is new for you. And I think we can wrap up the session. And for every other query that any of the audience people might have, LinkedIn IDs of Arvind and Pranav are given in the description. You can reach out to them there, and they'd be happy to cater your queries. I hope I'm right? Yeah.
Yep, absolutely.
So
Absolutely.
thank you so much, Arvind and Pranav, for taking out time for us and all the students. And I'd be wrapping up the session now. So thank you, everyone.
Bye,
Thanks,
folks.
everyone.
Bye-bye.
Thank you.
Thanks.
Bye-bye.
Bye.
Thank you so much, people. Thanks for joining.